Okay, so we're ready for our topic, which is simplifying radicals and rationalizing the denominator with radicals. So the first one that we're going to work on today is when we have just a single radical in the denominator. What do we do? So let's get started. Okay, so I use the word rationalize the denominator. Let's just talk about what that means on there. So when I mention the word rationalize, what it means is being able to rewrite a radical expression. And what I mean by a radical expression is just any expression that has a radical in it. As an equivalent expression in which the denominator no longer contains any radicals. So what we're going to be looking at is fractions in which the denominator has a radical in it. Now, there's multiple ways that you're going to see that denominator written where there's radicals in it, but we're going to start with the simplest one. And that is if we have something like just the square root of b. Now, what do I mean by that? So what I mean by that would be is if you had just maybe a number, so something like 3 over the square root of 2. That would be what I meant when I mean just over the square root of b. And so in order to rationalize this, what we do is we just simply take the denominator, we look at it, so the denominator is our guiding force here that's going to tell us what to do. It says the square root of 2. And so what we're going to do is we're just going to multiply both the numerator and the denominator by the square root of 2. Okay? Now, in earlier videos, we talked about what is the square root of 2 times the square root of 2. And again, it is the whole number 2. And then we also talked about what you do when you take a whole number times a radical. It just stays 3 square root of 2. And that's all you have to do, guys. Now, we'll make them a little bit difficult here and there, but for the most part, that is your steps, okay? So let's just write those down. So what do? Okay, well, we multiply numerator and denominator by the radical expression in the denominator. Okay, so again, the denominator here is our driving force. It's going to tell us what we're going to do. So we're going to multiply here in our denominator. Okay, and then after that, it is simply, guys, that we're just going to simplify. Okay, so we're going to simplify by multiplication. Okay, so again, not too many steps and not very difficult. So hopefully that will make sense. Now I'm going to go ahead and run through, I think, 4 or 5 for you real quick just to give you some examples. But again, just a preview of what we're going to be doing in class and be using all during this unit here. So let's go ahead and get started with our examples. So here's going to be my first one that I'm going to give you, and it is 3 over the square root of 7. So very similar to what I gave you earlier. Again, the process that we're going to do simply is to multiply both the numerator and the denominator by the radical. So in this case, the square root of 7 to both the numerator and the denominator. And then again, your next step is just to simply multiply. So 3 times the square root of 7 is 3 times the square root of 7. The square root of 7 times the square root of 7 is 7. Okay, so look at that. Make sure that makes sense to you. Let's do the next one. Oops, lost my division there. So 2 divided by the square root of 6. Again, we're going to just multiply both top and the bottom, numerator and denominator, by the square root of 6. In this case, I get 2 times the square root of 6 over 6. Now, this one has just one little twist that's different in it. And that is the fact that if you look at the 2 and the 6, that is just like a regular fraction, okay? And we can reduce down to 6. And so what we're actually going to do is have, go back to a different color, what we're going to actually have is, again, 1 over the square root of 6 over 3. So see, I took that 2 6 and I reduced it to 1/3. Now, do you need the 1? No, you do not need the 1 because the square root of 6 is holding that numerator place value. So you can leave it there or not. Most of you probably won't want to put it there, but it's not wrong if you do leave it there. Okay? Okay, number 3. Now I want to give you number 3 because if you look at this one, hopefully a couple of things. One, you notice that everything is under the radical, not just either the numerator or denominator. And so if you see that kind of problem where both the numerator and the denominator are all underneath the radical, you can actually break that apart. That is a legit step. It's just to break it apart into 2 radicals. Okay? And then the square root of 25 is 5, and the square root of 16 is 4. Now, some of you probably could have gone straight to that step and not broken apart just because you saw that they were both perfect squares. That's awesome. That's fine. That's not always going to be the case, as in number 5 when I do it in a few minutes. Okay, number 4. If you look at it, you'll see that it's different in the fact that it's very similar to 3, except that I've already have it broken apart, but they both contain square roots. So again, the driving force is your denominator. So I'm going to multiply both numerator and denominator by that square root of 5. 2 times 5 is 10, so I have the square root of 10. The square root of 5 times the square root of 5 is 5. Okay? Now in this case, that's all you can do. If you look back at number 2, I divided the 2 and the 6, but those were whole numbers outside the radical. In this case, that square root of 10 is inside the radical. So you cannot break into the radical. Okay, think of that like a barrier. You cannot break into a square root. Okay, that would be your final answer right there. Okay, and then number 5 puts kind of 3 and 4 together. So first off, it is all under the radical, so I can break it apart. Now I'm back to question 4. So I'm going to multiply. Okay. And then again, square root of 3 times the square root of 5 is the square root of 15. And the square root of 5 times the square root of 5 is 5. And that is your final answer, because again, we cannot break into a radical. Okay, so that just gives you some examples. Again, it's just a quick preview of what we're going to be doing later on with radicals. Of course, we're going to do some twists and turns and all kinds of stuff, but that's kind of the basic concept. If you can get that, you shouldn't have any trouble. So again, in class, we'll be doing more. If you have any trouble with these or something didn't make sense, be sure you make a note in your notes. Come back in and ask me about it. But be sure you have these written in your notes. And if you missed anything else, back it up and get it into your notes so that you have it for discussion in class. Thank you, and talk to you later.